Here we have a problem on quadratic equation. Okay, let's go with the question. If 2 to the power of 2x positive 3 negative 3 to the second power times 2 to the x power positive 1 equals to 0, then values of x are. Okay, in this equation, I have to find the value of x. Okay, let me write the given equation as it is. That is 2 to the power of 2x positive 3 negative 3 square times 2 to the power of x positive 1 equals to 0. Okay, here when I consider the first term, we have two values are added at the exponent. Whenever two values are added at the exponent, what we can do is we can take this base separately for this one and multiply the results. That is 2 to the power of 2x times 2 to the power of 3. So that is I'm using the product rule of exponents. That is we multiply two terms with the same base. Let me consider a to the mth power times a to the nth power. It results a to the power of m positive n. That is when we multiply two terms with the same base, we have to take the base ones and we have to add the exponents. So we just do the same thing in reverse order. That is here we have two values are added at the exponent. We take this base a separately for this one and we multiply the result. That's what I've done over here. Okay, and also the value for this 3 square is just 9. That is negative 9 times 2 to the x power positive 1 equals to 0. Okay, now let me consider the power of a power rule in exponents. That is a to the mth power whole to the nth power. So here we have base a and we have exponent m, and for this complete stuff we have again exponent. Whenever we have two exponents like this, so what we can do is we can multiply the two exponents. That is m and n can be multiplied. Okay, now let me consider from the right side to left side. So when I consider the stuff on the right side, at the exponent, two values are multiplied, m and n. So whenever two values are multiplied at the exponent, what we can do is we can take one of these two values as exponent for a. So here we can take m as exponent for a, then we get a to the mth power. The second value can be taken as exponent for the whole stuff. So not only like this, if I want the same stuff, that is a to the a to the power of m times n. So here two values are multiplied. One of these two values can be taken as exponent for a. Now this time let me take this n as exponent for a, then we get a to the nth power, and the other value should be taken as exponent for the whole stuff. So a to the power of m times n can be written as in this way or in this way. Both the ways are correct. Okay, now let me consider the first term we have here 2 to the power of 2x. So here at the exponent two values are multiplied. So now what I can do is I can take one of these two values as exponent for this base 2. Let me take this x as exponent for base 2. Then the other value 2 should be taken as exponent for the complete stuff as I explained over the stuff here. Okay, and also the value of this 2 to the third power is just 8, negative 9 times 2 to the x power positive 1 equals to 0. We can write this 8 in front of this 2 to the x power the whole square. Then I'm getting 8 times 2 to the x power the whole square, negative 9 times 2 to the x power positive 1 equals to 0. Okay, here I find 2 to the x power and here I find 2 to the x power. So to make a further solving of this equation easier, what I'm going to do is I'm going to assign a new variable for this 2 to the x power. That is let y equals to 2 to the x power. So here we can plug in y, here we can plug in y. So then I'm getting 8y square and negative 9y positive 1 equals to 0. Okay, now I got a quadratic equation in terms of y. So I can solve for y in this quadratic equation. I'll be getting two values for y because it's a quadratic equation. Once I get the values of y, I can replace y by this original stuff 2 to the x power. Further, I can solve for the original variable x. Okay, now let me continue this on the next page. This is a quadratic equation we have had on the previous page. Okay, I think this quadratic equation can be solved by factoring. Further, we have to multiply the constant term positive 1 by the coefficient of y square, that is 8. 8 times positive 1 is positive 8. Now I have to get two factors for this positive 8, so that the sum of these two factors is equal to the coefficient of y, that is negative 9. I think negative 8 and negative 1 will work. When I multiply negative 8 and negative 1, I'm getting positive 8. And when I add them, I'm getting negative 9, which is the coefficient of y. Further, I have to divide these two factors by the coefficient of y square, that is 8. Let me divide both these factors by the coefficient of y square 8. So when I simplify this one, I'm getting negative 1, that is 8 divided by 8 is 1. And this one cannot be simplified anymore. We have to keep this one as it is, that is negative 1 over 8, because 1 is not divisible by 8. Okay, now to get the two values of y in this quadratic equation, what I have to do is I have to change the sign of each of these two factors. If I change the sign of the first factor over here, I'll be getting the first value of y. It's already negative. If I change this sign negative, I'll be getting positive. That is the first value of y is 1. And to get the second value of y, I have to change in the sign of the second factor, then I'm getting 1 over 8. Okay, now I got the two values of y. Now actually y is taken by as, so it has to be replaced by the original stuff. We know that y equals to 2 to the x power. Now we can plug in this 2 to the x power for y over here. Okay, let me do it. Let me plug in 2 to the x power for this y, then I'm getting 2 to the x power equals to 1. And here let me plug in 2 to the x power for this y, then I'm getting 1 over 8. Okay, 2 to the x power equals to, so here I'm trying to solve for the variable that is at the exponent. In an equation, if I'm trying to solve for a variable that is at the exponent, what I have to do is I should be getting the same base on both sides of the equation. Once I get the same base on both sides of the equation, I can equate the exponents and I can solve for x. So here we have a power of 2, that is 2 to the x power. So that is we have base 2 on the left side. So on the right side also we must be getting the same base 2, but here we have 1. So how can we write this 1 as a power of 2? So it can be just 2 to the 0th power, because anything raised to the 0th power equals to 1. So instead of 1, we can write 2 to the 0th power, because our aim is to get the same base 2 on both sides of the equation. Now we have the same base on both sides of the equation. So if two terms are equal with the same base, we can equate the exponents. When I equate the exponents, I'm getting x equals to 0. Okay, I got a value for x, that is x equals to 0. Okay, now let's solve for x in this equation. So the same thing. So here we have variable at the exponent, so we should be trying to get the same base. So here we have base 2. So on the right side also we should be trying to get the same base 2. Okay, let me continue. 2 to the x power 1 over this 8 can be written as 2 to the third power. Then we get 2 to the x power equals to. So this 1 over 2 to the third power can be written as 2 to the power of 1 negative 3. So here I got the same base on both sides of the equation. So since these two terms are equal with the same base, we can equate the exponents. Then I'm getting x equals to negative 3. Okay, now I got two values for x. One is 0 and other one is negative 3. Okay, now let's go to the question and we can verify the options where we get these two values for 0 and negative 3. Okay, we get 0 and negative 3 in answer choice D. The correct answer choice for this question is D.